Hello, Math 151. Let's do a problem from related rates section. Water is leaking out of an inverted conical tank at a rate of 8,000 cubic centimeter per minute. At the same time, water is being pumped into the tank at a constant rate. The tank has height of 8 meters and the diameter of the top is 7 meters. If the water level is rising at the rate of 15 centimeters per minute, when the height of the water is 1.5 meters, find the rate at which water is being pumped into the tank in cubic centimeters. So notice here that some of the information is given in terms of meters and some in terms of centimeters. So I'm going to go ahead and change everything into the centimeter to make my life easier. I'm going to go ahead and get my iPad involved. That way I can write on it. So here's what we have. We have a tank, an inverted conical tank. So we are given that the height was 8 meters, that means 800 centimeters. The diameter on the top was given to us at 7 meters, which is 700 centimeters. Therefore, this radius is 350 centimeters. Okay, we know that the rate that the water is leaking out, so change of volume dV dt out is minus 8,000 cubic centimeter per minute. Okay, and we know that when H, or the height of the water, when this, let's say this is the water, when the height of the water is 150 centimeter, then dH dt is 15 centimeter per minute. So the height of water is rising. That means that the water in, the rate at which the water is pumped in, is faster than the water leaking out. That's why the height of the water is going up. Let me go ahead and go to the next page. I'm going to go ahead and use the similar triangles, one using the entire cone. And let me change this one to the water level so I can get, I have a right triangle here also. So at H equals 150, I know R. So let me just do a little bit of naming in here. So this is the big triangle. We know this is 350, that doesn't change. We know this is 800, that doesn't change. But for at that precise moment that the height of the water is 150, let me just call this one radius, because as it is, it keeps changing, and call this H. So at H equals 150, I know R over 350 equals 150 over 800. Okay, dropping the zeros. So drop these zeros in here. And I have R over 350 equals 15 divided by 5 gives me 3. 80 divided by 5 gives me 16. And so if I solve for R, I get R equals 3 times 350 divided by 16. That gives me 3 times 5 is 15. 1050 over 16. So I can claim that R equals 525 over 8. So let's just save this for now. Going to the next page. In general, we know that R over 350 equals H over 800. So if I solve for H, I get H equals 800 times R over 350. Simplify that, the zeros drop. Dividing by 5, I get 16 over 7R. And if I solve for R, I get R equals to 7 over 16H. So let's just save this also. Going to the next page. I know that volume is 1/3 pi R squared H. So volume equals 1/3 pi R squared. H was given as 16. Actually, we found out it wasn't given. We found out just a minute ago that H equals 16 over 7R. If I simplify that, I have volume equals 16 over 21 pi R cubed, pi R cubed. And now I'm ready to take the derivative from both sides of this equation. On the left-hand side, I get dv dt, dv dt equals 3 and 21 simplify, so I have 16 over 7 pi R squared dr dt. Okay, so let's go to the next page. But what is dv dt? In this case, change of volume in relation with time is the volume in, the combination of volume in and volume out, because water is pumping in and water is leaking out. So I can write that dv dt, dv dt, and I'll just put like here in plus dv dt out equals 16 over 7 pi R squared dr dt. What other information we had? We found out that dr, let me take you to the previous pages, that we had R equals, maybe next page, right here. Notice that we found that R equals 7 over 16H. I'm going to use that information and claim that if R equals 7 over 16H, then dr dt equals 7 over 16 dh dt, and dh dt was given, is given, and that was 15 centimeter per minute. The problem was given that. Now, so let's go right here. So dr dt, so dr dt equals 7 over 16 times 15, and that gives me 105 over 16. Okay. And of course, the unit is centimeter per minute. Let's go to continue maybe in a blank page. So we had dv dt in minus dv dt, actually plus, because we are combining them together, dv dt out, and we had that as 16/7 pi r squared dr dt, and we just found out what dr dt is at 105/16. So dv dt in this was given to us as a rate as 8,000, and since it's going out, I'm going to write here minus 8,000 equals 16/7 pi. Dr dt was r squared. R, where is R? What did we find out what R was on those pages? R, right here, 525/8, 525/8. So 525/8 to the second, and dr dt was 105/16. So now dv dt equals dv dt in equals 8,000. Add 8,000 to both sides of this equation, plus 16/7 pi, 525/8 quantity squared, 105/16, and that approximately equals to, putting it in TI, 8,000 times 16/7, here's pi, times 525 divided by 8 quantity squared times 105/16. So my calculator is giving me 210,945.65 210,945.65, and that's cubic centimeter cubed per minute. Okay, thanks.